Myself, Mihir Rajendra.
Myself, Ram Manish Sarade. Your project is Revolution on Quantum.
So now let's start with the scale of universe. In universe we find many particles like nanoparticles, dust particles and quantum particles. Quantum particles, yes, at this smallest scale, the strange and powerful laws take over. Laws which classical physics cannot explain. And here it is, the quantum technology is born. So now let's see why do we need quantum technology. First is limits of classical thinking. Classical technology like phones, computers, video games have helped us a lot, but they fail to work at the smallest level. In the shift towards quantum scale science, in nowadays world, in the modern world, we have to shift towards quantum scale science to gain our confidence in life and also help us in day-to-day life. In understanding complex natural phenomena, complex phenomena like how lighting works, how molecules behave at the tiniest level, how materials react, complex or classical systems fail to adapt to this kind of technology. New era of information and communication, as we know that this is the whole new era of information and communication, and if we fall behind, then there is no space for us in the world to survive. Now let's see some potentials and concerns of quantum technology. First is complex problem solving. Complex maths of problems can be solved within seconds, and in medicines we can discover many new drugs, many new medicines and many new vaccines. In climate modeling, we can forecast the weather, we can forecast the climate and know when it is going to rain, and it also helps our farmers. Then advanced encryption. In day-to-day world, as we know, many hackers can hack our passwords. But now in advanced encryption, we can make passwords which are unbreakable. In financial optimization, most of the Indians don't know about stocks, mutual funds. They don't know what is stocks, how to invest in mutual funds. Quantum technology can help them in that. In artificial intelligence, as we know, the quantum technology can revolutionize the field of AI, helping them in machine learning, quantum tech, and etc. But as you know, every rose has its own thorn. Every potential has its concern. First, security algorithms are not developed. As I told you that it can suggest password, but it can also help hackers to hack our systems, and that's why this problem of security algorithm arises. In possibility of errors, the quantum systems have qubits which they are made of, and they can have possibility of errors in them. In temperature requirement, do you know that the quantum systems have to be kept in minus 273 degrees Celsius temperature? And that's why it is very expensive to make. That's when we come to our next point, loss of jobs. As quantum systems are doing almost everything, people are no longer needed to do that kind of job. And to have to program, the programming language or the coding language of the quantum system is really hard to achieve. But as we know, every cloud has a silver lining. Every concern has its own solution. How can we tackle the problem of security algorithms? Security algorithms are not developed, but as they will evolve with time, they will get better and better. What can be the solution to make this computers cheap? By making such materials that can trap heat inside, they don't have to be kept in minus 273 degrees Celsius temperature, and that's how we can tackle the problem. How can we reduce the possibility of errors? By making 3 qubits. As I told you that 1 qubit can have possibility of errors, but when 3 qubits combined with 1 do not have any problems. What about the programming language and temperature requirement? Programming language of the quantum computers is really hard. So that's why we need people, and that's one other issue, that is the loss of job is also cured. Temperature requirement, as I told you, the material should be made in such a way that they can trap the heat. So that's all from us. Thank you.